The guys have told me that there's lots of stuff for me to look at. So with that, let me just go over here and we're going to remove the frunk. So let's pull this thing out.
Corey, get the Octovalve.
Oh, thank God. Oh, Corey. Oh, I think you just saved my life. Holy I can't believe it. What just happened? Okay, so we dramatized that a little bit, but it was something that almost happened when I first saw the underneath the frunk. I was very shocked.
Welcome back, everybody. If you're new, my name's Nicholas, and this is Investing Against the Grain. Before we get into today's video, I want to give a special shout out to all of our subscribers. We are sitting at 64 subscribers now. We had a goal of hitting 60 by the end of last week. By Friday, we had exceeded that to 64 subscribers. So special shout out to everybody who's helping the channel, who's subscribed, and who's enjoying this content. Please, in the comments below, give us your feedback because all the feedback you give us help us improve the content for this channel. Now, with that said, we do have a bigger goal of hitting 75 subscribers by the end of July. Okay, that's right around the corner. We're at 64 right now, so we have 11 subscribers to go. So do us a favor, if you enjoy this type of content, hit the like button, hit the subscribe button below. Okay, now in today's video, we are going to be reviewing the breakdown that Sand Munro did of the Mustang Mach-e's thermal management system. This is arguably the biggest competitor to Tesla. So to truly invest in a company and understand where it's going and its advantages and disadvantages, we really have to understand where they stand in comparison to the competition. So that's going to be the impetus of this video today. Okay, so again, if you enjoy this type of content, help us out. We have 11 subscribers to go. Hit the like button, hit the subscribe button, and let's get into it.
Hey, hi, boys and girls. Today we're going to do a little bit of a comparison. You've already heard us talk a little bit about the heating and cooling system that we've got here on the Tesla Model Y. Today what we're going to do is we're going to compare this. We're going to compare the Model Y heating and cooling system to what we found on the Mach-e. And I think you're going to be surprised by the differences that we found.
Okay, so as Sandy just said, the whole point of this video is just comparing and contrasting specifically the Mustang Mach-e and the Tesla Model Y. So just, when we're going through this whole video, please keep that in mind that, that is the comparison being made here is between the two. And also keep in mind as you go through this that according to Sand Munro, who is an expert in this field, right? This is what he does for a living. He does this for military companies, for other auto companies. He's done missiles, rockets, right? This is his wheelhouse, right? This is his cone of expertise. According to him, he believes that the Mustang Mach-e is the second best EV out there. So again, as we go through this, keep in mind, we're looking at this from an investing perspective to understand where Tesla is and where the competition is. And this will allow us to know whether or not there's competition coming for Tesla. How far back are they? Are they about to overtake Tesla? Right? We want to try to be unbiased and we want to keep this frame of thought the entire way through this video.
So with that, Corey, it's all yours. I'm going to get out of the way.
Now the first thing I want people to notice here is location, location, location. Many of the components for the Tesla Model Y are very close together. What Ben is going to do is he's going to bring the corresponding pieces and parts that we found on the Mach-e, put them on the table, and then compare and contrast the hoses and lines that run between them. Right here is the R1234YF pump. Notice it's hanging off of this cross-car bracket from the Tesla Model Y. Tesla chose a steel bracket to go across. Ford chose an aluminum. But as we look at how things are mounted, how they're isolated, and the distances apart, we can see that Tesla focused heavily on getting everything as close together as possible. If you look at the back, because this is a heat pump system, the lines run in an exact straight line. When comparing and contrasting to the Ford Mustang Mach-e, you'll notice that the lines are not nearly as concise. So Ben, do you want to go ahead and grab the first component to compare, and we can talk through the differences?
For those of you who don't know, I've mentioned that I'm a software system engineer and I design and build data centers. But before that, during my 20s, I was actually a marine engineer. As a marine engineer, your discipline is in mechanical, electrical engineering, right? So you're essentially an engineer of engineers. You have to know everything from hydraulics to electrical system to electronics to mechanical, how things work from a mechanical standpoint, whether it's generators or engines, right? You have to have the whole spectrum when it comes to engineering. Now, this is very reminiscent of a lot of things that I would see in my previous career, again, during my 20s. And when he's mentioning location, the reason this is so important is because that is where you can see the true design of the engineers who are building the system together. What's very clear with the Tesla system is that they don't have different silos of engineers. Instead, they have engineers all collaborating, working together, and that shows the cohesiveness of the design. So when he's sitting there saying that it's a very straight path, what that means is there's no angles, there's no excessive amount of hoses or pipes running through this. The benefit of that, one, is more efficiency. Because there's less turns, you get more of a direct shot, right? So you don't lose any kind of efficiency whenever any of the fluids that are cooling the entire system off, whether it's from a 90-degree angle or from just excessive amounts of hose or pipes. So this is very important. The less you have, the better, especially when it comes to electric vehicles. So let's see how this compares to the Mustang Mach-e.
All right, well, first we're going to grab all the lines that the Mach-e has, which is, as you can see, a whole bunch of lines when compared to what the Tesla Model Y had. There's actually 35 different hoses here, which is a very large number when looking at the thermal system. And then pulling out a few of the other parts that Corey had just talked about, we'll start with the bracket that they're using for mounting most of this. This is the crosscar beam. This also holds the motor up as well as the electronics. So Ford is doing more than just the thermal systems with this component. So it is much larger than what it needs to be, but it would be the equivalent part in the Mach-e. And then we also have the compressor that the Mach-e is using, but it's not mounted just like that. There is a noise isolating diaper that goes around it, and they have a bracket and then an isolator to hold it in place. So there's a lot more that's happening with these parts. And then Corey also mentioned the refrigerant lines there and how they were very straight and to the point with their design. These are very turned, they're very bent, not a straight line ran here, so they have to wrap around parts to get to where they need to be.
Okay, so a few things we just saw there. One, the actual mounting bracket. I actually like what Ford did here, going with aluminum versus steel. Tesla's with steel. There's a lot that goes into that. I'm sure some of it had to go with structure or just making sure that it's beefy enough. Aluminum tends to be more lightweight, so that's why I gravitate towards aluminum. But you can't always do everything in aluminum. Now, what we also see here is a bracket for several different pieces, right? For the compressors, you'll see it for motors, you'll see it for pumps. One thing you should always know, anytime you need to add brackets, that's a telltale sign of bad design, right? With the Tesla's system, everything was intuitively designed so that you don't have to have these excessive brackets. Right, everything is essentially mounted to one manifold so that we don't have to have a bracket here, a bracket there. We have everything designed so that it fits in as compact form factor as we can. The reason we really don't want anything with brackets as well is because when it comes to EV, it's all about weight. Weight is the name of the game. You can't get better mileage with the EV just by adding a bigger battery. Right? You have to reduce the weight. You have to reduce the coefficient of friction overall. So when we see all of these extra brackets, when we see all of these extra hoses, right, that just means more weight, more parts, less efficient design. Now, the last thing we see here, the reefer system or the refrigerant lines, as he's referring it to. The reefer system, you really want a path of least resistance. Okay, and as you can see here, everything is bent. There's multiple 90-degree angles, and with any reefer system, any refrigeration system, you'd want as minimal amount of 90 degrees as possible. So let's continue to see what we get moving forward.
So, Corey, if you want to take a look at some of the next parts.
Yeah, so the next thing we're going to talk about is the valves and the ethylene glycol system. So we have one bottle here. The Ford Mach-e has multiple bottles. The valve, the Octovalve, which we've covered at length in previous videos, we may pop up a little video how that works, that quarterbacks the fluid through the systems. So rather than having a disassociated valve and disassociated pumps, the pumps and the valves are all right here. We've reassembled this system to give the viewers a sense of how close the items are packaged together. And you can see one motor, one valve, all within a few inches of each other. And the bottle is connected to the nylon manifold that flows all the fluid throughout. Another item that we're going to talk about as I spin this around is the liquid cooled condenser.
Keep an eye on the condenser that was just pointed out. So mainly you can see that the condenser is, you know, the small square that you can see near the top. I'll show it again to you guys a little bit later, but I just want you to I want to point that out because the size of that condenser is a fraction of the size of the Mustang Mach-e condenser. And again, as is the same, you know, story, the same message over and over when it comes to EVs. Size matters, weight matters, and we want things to be as streamlined as possible. One other thing, so he's talking about the motors, the pumps, the valves being as closely packaged together. So this is a big deal just from the standpoint of having to have less hoses, less wires, right, things of that nature. But it's also a big deal because with the Octovalve, and if you're not sure what the Octovalve is, I highly recommend you watching Sand Munro's breakdown of the Octovalve. Essentially, it's a whole bunch of valves in one cast form that opens and closes as needed, right? As fluids come through, right? We're managing all of that. I'll actually put a link of the Sand Munro video of the Octovalve below. It's quite complex, but just a brilliant, simple design. It's ingenious. It's very surprising that more of the auto companies such as Ford, GM haven't just broken down a Tesla and copied it almost exactly. Especially since Tesla has all the patents open. I imagine the Octovalve is a patent that is open as well. But yeah, so I just wanted to break up real quick just to point out the condenser itself. So we can continue here.
And the chiller. The chiller on the Ford Mustang Mach-e is located on the right rail. Ben can pull that part out and we'll show how that chiller is mounted. This chiller is mounted directly to this semi-solid forging. This allows for 0 lines between the R1234YF system and 0 lines from the ethylene glycol system. So Ben, can you pop up that the chiller?
We will grab the chiller next. We have the chiller, and then of course they need a mounting bracket to be able to put that to the right rail. And then a few of the other components that Corey had just gone over. There are 2 bottles reservoirs on the Mach-e. There are 2 coolant loops that they are using, so they need to supply both of them. They are the same part, so they did get some commonality out of it. But they have a coolant loop for their battery that runs through their PTC, and then the heater, the cabin heater. And then their other loop runs through their electronics and motors. And because of that, they need to have multiple pumps in their system. They have a total of 4 pumps. Here are 2 of them and their corresponding brackets. And then again, there are 2 loops, 2 more pumps for the second loop. Because they have so much hose, they need to have more pressure to pump them through the system. And then they have valves as well because they are changing how their coolant is run depending on how, what conditions the vehicle is being ran in. They have a 4-way valve, and a two-way valve that they use.
Plus bracket.
And then again, as Sandy said, more brackets. And some more brackets there on the table back here. So they have brackets that are holding all of their parts together. There's a lot of fasteners that go with each of these brackets as well. So there's a lot of assembly time to put this all together.
Yeah.
Here we see, again, I mean, you can see the table now, right? It's starting to really be flooded with parts, while the Tesla just seems so compact. What you should notice here right off the bat, brackets on top of brackets on top of brackets. Like I mentioned before, that's poor design, that's siloed engineering, that isn't a overlap, intuitive nature of engineers and teams working together to figure out how we can make this as simple as possible, as streamlined as possible, making sure that every turn of every hose, every reefer line, making sure that everything is intentional, not just, hey, we need to have this part, so let's just figure out how we're going to run this line from here to there. Okay, all the excessive brackets are indicative of too many components, right? They have two loops, cooling loops throughout the vehicle. So that means you need more pumps. And the reason you need more pumps is because there's so many hoses that you need to have basic flow analysis, right? We need more throughput from one end to the other end. And the only way to do that, to have enough pressure for that, is to add another pump, right? So this is a very poor design. Had they have been more intentional with how they were routing their hoses based on the design and thought about these things further, maybe they would use less pumps. Maybe they would have less brackets. But I know a lot of this seems like, okay, who cares? You have a little more here, a little more there. But you'll see over the course, it starts to add up. And again, like I've been saying over and over, weight matters with an EV. You are not going to get more range by having a bigger battery. You're going to increase your range by having better battery chemistry and by having less weight and a reduced coefficient of friction.
Sandy's initial reaction was genuine. I know he called this a nightmare. That may have been a little bit of a stretch.
When he's talking about Sandy's initial reaction, it's the intro of this video where Sandy looked at it and he pretended to faint and saying that it was disastrous or a nightmare. Again, just once he pulled out that frunk, he saw immediately. He saw the rat's nest of hoses. Right? Normally, when we think of rat's nest, when it comes to any kind of engineering, we think of like data centers with all the cables, just a mess with horrible cable management. Somehow we saw that with hoses within the Mustang Mach-e. So I just wanted to clear that up. That's what he's referring to, is what we saw at the beginning of this video.
But when we look at designs, we're not necessarily looking at just cost and weight, but we're looking at sometimes the elegance of how things are designed. Seeing these two pumps directly mounted to a manifold on the Tesla, seeing those four pumps mounted separately with their own brackets, sometimes two brackets, that causes us to think, what were those decisions that went into designing this? And Ben and Sandy, you can hit on the amount of hoses that we had on the Mach-e versus the amount of hoses that we had on the Tesla.
Well, we've still got a couple more spare parts here that we have to kind of address in order to make this compliant, I guess.
Right, and one part that is on the Model Y that Corey hasn't mentioned yet is the 12-volt battery. That's just where Tesla chose to place it. It doesn't have anything to do with the thermal system. We're just trying to show equivalency here. So we have a battery and a battery tray that went with it.
With the 12-volt battery, keep in mind, this is just a traditional lead-acid battery. It isn't it's not a lithium-ion battery. Tesla will be coming out with that. I actually think that in the Model S, it is a lithium-ion now. Don't quote me on that, but I think I saw some things from Emmett Brown, perhaps. I think he had mentioned that. But either way, going to a lithium-ion battery is going to save a lot of weight. I also want to touch on one other thing. He was talking about how Tesla has the pumps directly attached to the manifold. So to simplify this, picture a manifold as this cylindrical pipe that has a whole bunch of openings where I can directly attach a pump to it. So if I have this manifold here in front of me and I have this pump directly attached to it, that means I don't need any hoses, I don't need any brackets or anything. Whereas for the Mustang Mach-e, you have this manifold and then you have a pump over here, and I need to route a hose from this pump all the way to that manifold, and then I need a bracket to mount that pump onto the vehicle somehow, right? And then of course, on the other side of the pump, there has to be another hose, right? Because there's an inlet and an outlet. So this is just, adding more weight, adding not just from the hoses or the brackets, but also the more hose you have, the more fluid you need. And that fluid weighs a lot. So, this is why it's subtle when they mention attached to the manifold, but it's a very big deal.
And then we have the parts that are equivalent to the LCC and the heat pump that Tesla is using. We have you want to grab that one? We have the PTC heater with 2 brackets for the PTC heater. And then we have the condenser, which is located at the front of the vehicle.
This is the condenser.
Okay, so this is the Mustang Mach-e condenser. So as promised, I went ahead and clipped the recording from before whenever they showed the Tesla condenser. So you see this one here. Now let's go ahead and look at the condenser for the Model Y.
Is the liquid cooled condenser.
So that was very quick, it was very short, but you can see the dramatic size difference between both, right? One's very compact, the other one is, almost a half the size of Sand Munro himself.
So we started looking at this, and you recall when I was working with the Chinese on their products, I had a little rule: every engineer 1 gram every day. So we have a look at this, and we have a look at that, and we just start. we decided we'd put down a little bit of the size and weight associated with this design versus what we have here at Tesla. So if we look at the Mach-e, the number of pipes and whatnot, if you stretched them all out into one, you'd have 18.42 meters. That's quite a ways. If you look at the Model Y, you're looking at 6.35 meters. If you look at the number of hoses here on the Mach-e, you're looking at 35 parts. Over there, you got 10. Okay, so we go back to grams.
So I want to pause it there real quick to address this chart. So we see the length of hose. On the Model Y, 6.35 meters versus 18.42 meters for the Mustang Mach-e. Okay, 6 times 3 is 18. That means there's a 300% more usage of hoses with the Mustang Mach-e compared to the Model Y. 300%. Now keep in mind, this is just talking about the length. As far as the hoses, we haven't even talked about the weight of those hoses themselves. Then we talk about part counts. 10 pieces versus 35 pieces. Again, this is over 300% increase compared to the Model Y. Fluid. I mentioned this before. All that extra hose means there's more fluid needed for the system, right? So if you need more fluid, it means you have more weight within the car, within the vehicle. So again, this is over 100% increase in weight just in the fluid compared to the Model Y. All of this starts to add up. This is a big deal because no one's going to be able to catch up to Tesla if they cannot at least be on par, on parity with them when it comes to weight, right? This is why design is fundamental. Design is everything, right? We're taking very complex things and we need to make them simple. And that's very hard. It's very difficult. And this is why other OEMs are struggling to catch up to Tesla. This is why when you hear a lot of people, I mean, like myself, right? I admit it. I'm a fanboy. I'm biased. But these numbers don't lie, right? This is basic engineering. I mean, this is even engineering. I can take a 6-year-old and say, hey, which one's bigger? Which one's more? Which one? This is basic things that are very intuitive to anybody, right? So this is why when people say the competition's coming, when people are saying, oh, here comes Ford, they're going to overtake Tesla, I don't see it. I really don't see it.
This, obviously, we're not going to put that into grams. You can add 2 zeros if you want, but at the end of the day, look at the weight just in the fluid, Now, people have been talking about the batteries. Oh, we had a bigger battery, so we're going to get longer range. You aren't going to get range if you can't get rid of weight. Remember, I keep saying the same stuff over and over again. I need weight reduction. I need a coefficient of drag that's low. I need to have really good friction characteristics. And I need efficiency when it comes to wiring and plumbing. This is where things start to fall apart on the Mach-e. But bear in mind, this is the second best product that we've looked at.
This is the second best product Sand Munro has looked at. Okay, he has taken apart hundreds of vehicles over his time. He has taken the Mustang Mach-e down. He's taken the Volkswagen ID4 down. He's worked with countless companies in China. He's doing some work with Apple that he can't disclose. And this is the best he has seen. Second best. And look how far away they are from Tesla. Okay, this is night and day. It's not even close. And you know what the scariest part is? Everybody's trying to catch up to Tesla where they are today. Okay? Tesla, they're innovating faster and faster. Elon was asked once, are you worried about other companies stealing your IP? And Elon said, no. In order to fight IP theft, you just got to innovate. That's the mindset they have. They have the mindset of the best part is no part. The best process is no process. This is not the standard way of thinking of a CEO or of any of these OEM companies. Okay, so this is why, Tesla's here, here's everyone else, and everybody's slowly coming up, and Tesla is just shooting out to the moon, right? Their innovation's going to the moon. No one's catching up, at least not anytime soon.
That's ponderous, isn't it? This is better than everything else that we've seen apart from Tesla. This is better than everybody else. So here's the deal. Everybody that's in the industry has really got to start looking hard at what's the competition doing, what are we doing, and how are we going to be effective in the future. This is a good example of how much of a difference there is between the Mach-e, the Tesla Model Y, and then try and picture what it would look like if we had something from somebody else which is even more dramatically different than what this is. Really and truly, if we're going to make a success in the EV world, every engineer, 1 gram every day. And in this case, 1 kilogram.
As Sandy Munro said there, imagine if the Mustang Mach-e is the second best, what everyone else would look like on that table compared to the Model Y. Now, this isn't to pick on the Mustang Mach-e or Ford or anything, but this is just to illustrate that this is what second best looks like and just the gap between Tesla and everyone else. Now, this was just a thermal management system. Keep in mind, Tesla is doing this on everything, from their casting, their batteries, their thermal management system, the way they paint the vehicles. There goes my ring again. It seems like it's always clockwork. Right as I'm recording, it goes off. They're doing it from their full self-driving. They're doing it with Tesla Energy, right? It's nonstop. Their material science, making alloys that nobody's ever seen except for one other company. Guess who that is? SpaceX. So good luck getting that material from them. It's just the iteration on top of iteration. And this just goes to show you that, this is a small microcosm of the big macro picture of what is Tesla. Now, okay, we're going to leave it there for today. Thank you guys again for helping us get to our 60 subscribers by the end of the week on last Friday. Again, we have a goal to hit 75 subscribers by the end of July. We are 11 subscribers away. So if you enjoy this type of content, if you want to see more, one, yes, hit the like button, hit the subscribe button, but do us a favor, comment down below, give us your feedback, because with your feedback, we can make better videos, we can get more information, right? Maybe there's something that you guys want to know more about that hasn't been covered. Let us know. I'd be more than happy to talk about it, to do the work for you. The whole point of this channel is so that if you want to invest heavily into Tesla, let me do the research for you. Let me do the homework for you, and I'll present it in the most unbiased way I can. Okay, so we'll leave it there. I appreciate you guys again. I love you all. Catch you next time.